Hey class, let's talk story problems. I'm sure you're all thrilled about that. However, there are some story problems and some things I want to point out that are just sort of rules and patterns we see in story problems. So while we're going to look at 4 problems in this video might be a little bit on the longer side. Remember, you can always pause. So I'm going to try and just give you the important information, and then you can pause if you need to slow down to write something. Hopefully, these are the ones we are more familiar with and we feel more comfortable with. So the first type of story problem we're going to look at today, I classify as a total story problem. So a local graphic designer charges $25 for creating a t-shirt design and $12.75 for each shirt printed. If the math club has a bill totaling $216.25 for t-shirts for its members, how many members purchase shirts? Okay, so first thing, don't ever feel overwhelmed once you read a story problem. We're going to try and break it down into smaller pieces. So first thing, what is this problem asking us to find? Problem is asking us to find how many members purchase shirts, right? So we have this idea of number of shirts first. Okay, we also know that this is talking about a bill totaling. And whenever we're talking about a total of something, we know that we want to add. Okay, we're going to add stuff up and we're going to set it equal to the total, which is the format that we see happening right down here. Okay, this blank plus blank equals blank. Now, there's no limit to how many things you could add up. It's just telling you that you need to set it up with addition, and you're going to set it equal to the total. Okay, so we know the format we need to use. We know our variable. So let's start filling in some blanks. So we know that our total is going to be $216.25. That's straightforward being told to us. And we know we're going to have to spend some money on getting the design and on shirts. Now, this is a piece that I feel like my students typically don't know, right? Our teachers have just told us, well, did you read the story problem? Are you sure? Where do you put the variable, right? Just like read it again, circle the important information. There are actual rules. The rule says anything happening per item gets the variable. Okay, so that $12.75, right, is happening per shirt. Anything happening per item gets the variable. The $25 is just happening for the design. That's a one-time fee. The $12.75 is per shirt, so it gets a variable. The $216.25 is a total, so that gets nothing. Okay, so now we have an equation that says 25 plus 1275s equals 216.25. That's an equal sign. Okay, now you could have your first 2 numbers flip-flopped and have the 1275 first. That doesn't matter, right? The order of addition doesn't matter. So now we have something we can solve. Let's see. We'll undo multiplication with division. Hopefully at this point we're fine with solving. We'll do 191.25. And we get 15. Okay, so our question says, how many shirts were purchased? 15 shirts. So we should be taking from this example that if we're reading something about a total, we are using addition, and we are setting it equal to whatever the total is, and that anything that's happening per item is what gets assigned the variable. Those are the 2 important pieces we need to take from this story problem. Okay, so let's look at this. Alejandro has, oops, that's a typo, sorry, it's right in your notes, but not right on mine. $145 to spend on clothes. He can get shirts for $8 and pants for $33. He purchases 4 shirts. How many pants can he purchase? Okay, so what is this problem asking us to find? It's asking us to find how many pants he could purchase. So P equals pants. Okay, now Alejandro has $145 to spend. Alejandro has $145 total to spend. right? He can spend $145 total. So we know we want to be adding some stuff up and setting it equal to the total of $145. He's going to get shirts for $8 each. Maybe it's a bargain bin, I don't know. And pants for $33 each. Okay, anything that's happening per the item, per what our variable is, gets the variable. So P is for pants. The $8 is happening per shirt. That does not get a variable. The $33 is happening per pants. So that does get a variable. Now we can't just start solving yet because there's one more piece in here that we have to consider. It tells us that he purchases 4 shirts. So if he purchases 4 shirts at $8 each, right, that would be multiplication. That's just hopefully something we know. That's not a story problem thing. Oops. You can either replace that 8 with 32, or you could write the 8 times 4. Either way is fine. So now we have 32 plus 33p equals 145. And again, our solving, we're undoing our addition and subtraction first. Hopefully we're okay with that. And then we're undoing multiplication with division. I'm going to check that value really quick. So 113 divided by 33. Money, so you hardly ever see me use decimals, but we got money and items going on. It doesn't really matter here. So when we solve this, we get 3.42 repeating. But let's talk about what's reasonable, right? Alejandro can't purchase 3.42 repeating pants. That's ridiculous. Okay, so let's talk about what we do know. We don't just want to go back to basic math rounding rules. We want to know that Alejandro at most has $145 to spend. So at most, we said was our inequality symbol of less than or equal to. So really, we need our P to be less than or equal to 3.42. So that tells us to go down. So even if this said 3.98, almost 4, right? We still have to go down because he doesn't have any more money. So we can buy 3, or Alejandro can buy 3 pairs of pants. Okay, so from this one, we want to take the important information here is that how we're going to deal with that answer when it isn't exactly a whole number, right? We're going to consider what it means. He has at most $145 to spend, and think about what way we need to round, not based on rounding decimal rules, but what way we need to round based on the amount of money or amount of whatever we have total. The second type of story problem that we are going to look at today is a comparison story problem. And again, I'm just sort of making up that label of comparison. I feel like this is super real world. I use this all the time. Sorry, this has a typo. I tell myself every year I'll fix it, and I never do. Taekwondo is with an E. But this is what happens when you have 2 options to consider. So you want to take karate or taekwondo. For karate, you have to pay a $100 enrollment fee and then $40 per class. For taekwondo, you have to pay a $50 enrollment fee and $55 per class. We want to give an explanation that helps us decide when it's cheaper to take one or the other, right? Do I want to go with AT&T or do I want to go with Verizon? Okay, do I want to go with a 30-year mortgage or a 15-year mortgage? Right? These are the types of things that you need to be thinking about. When is one going to be more cost effective? And in this situation, what we're going to do is set 2 things equal to each other to actually find when they're equivalent, right? If we set situation 1 equal to situation 2, we'll figure out when they're equal to each other and then interpret from there. Okay, so in this situation, we have the option of karate and we have the option of taekwondo. So we're setting those 2 things equal to each other. So karate is a $100 enrollment fee, so that goes over here. Karate is also $40 per class. Taekwondo, so that's going on the Taekwondo side, is a $50 enrollment fee. And it is also $55 per class. Okay, now anything that happens per item gets the variable. So we're gonna have to think about this carefully. What is happening per item? Well, man, we haven't even defined a variable yet. Okay, and this one doesn't have that straightforward question. But we're trying to decide when one is cheaper. So what is affecting how much we spend? What's making it cheaper or more expensive? And that's the number of classes we go to. So that's going to be our variable. Okay, so anything that's happening per class. So $100 is an enrollment fee, no variable. $40 is per class, so that gets a C. $50 is an enrollment fee, so no variable. $55 is per class, so it does. Okay, we know we want to set these equal to each other. Now we have to decide what operation we have to put in between that 100 and 40C. Okay, well, if we think about it, it's the total we're going to spend for karate. And we just said that total told us to add. So we're going to be adding these up. Okay, so then once we're here, this is just something we're going to solve. So I'm going to get my variables together, right? They're on opposite sides. So I want to use the opposite sign. The solving at this point should not be an issue. Okay, I'm going to undo addition and subtraction. And so I get 3 1/3 equals C. I can't attend to 3 1/3 of a class, right? So again, we need to think about this. But again, the question isn't just write down 3 1/3 and circle it and say you're done. The question is describe when one is cheaper. Because at 3 1/3 classes, if we could attend 3 1/3 classes, if those are the same, we then want to think about what is it going to be for the 4th class? Okay, on the 4th class, if they were already equal, on the 4th class, do I want to spend $40 or $55? Sorry, I got too far over and pulled that up. Right, these have already balanced out. We've already taken that into account because they were already equal at 3 1/3. So in the 4th class, do I want to spend 40 or do I want to spend 55? Well, 40 is cheaper. So if I'm going to attend 4 or more classes, then karate is going to be cheaper. But if I'm going to 3 or less classes, then taekwondo is going to be cheaper. Now, comparison problems don't always look quite as obvious. Okay, it's not taekwondo or karate type of situation. So in this one, an outfit costs $98. You will also have to pay $7.84 in sales tax. Okay, if we know that the tax on a coat is $10.80, how much is the original price of the coat? Oof, right? Well, what do we have here is a comparison. Well, we have an outfit and we have a coat. But this problem is talking about sales tax. So if we remember, right, sales tax is a percent that we pay on an item. And whenever we're talking about a percent, it's something out of 100, right? It's a fraction. A percent is a fraction over 100, a number over 100. So we're really talking about division here, fractions on each side. So we have an outfit that costs $98, and we're going to pay $7.84 in sales tax. Those are both pertaining to the outfit. So I'm putting those both on the outfit side. It does not matter which one you put on top, as long as when you get to the other side, you're consistent. The tax on a coat is $10.80. So the tax on the outfit was $7.84. I need that tax to go on the bottom over here. Okay, it then says, how much is the original price of the coat? Well, that's what I'm trying to find, right? The price of the coat. So I'm going to fill that in a C, right? This is the price of the outfit is 98. So in the same line, the price of the coat is my unknown. There's lots of ways you could choose to solve this. You could take that 98 and divide it by 784 to get a number on the left and then multiply by 1080. I'm just going to show with cross multiplication because we haven't talked about that yet. It's a good reminder, right? When you have two fractions set equal to each other, we can cross multiply to solve. I'm not saying this is the right way. I'm just saying it's a way to solve this. Okay, so 98 times 1080, 1058.4. So I'll just divide by 784. And that gives me that C equals 135. So the price of the coat is $135.